programming. I was lucky enough that my parents bought me another one, and I broke it again, trying to program. And then they said this, the last one we're going to buy it, and then your whole experience with computing is going to be over before you get started. They bought me a third Atari 2600, and I moved my pixel left to right. I went from the 2600 to PCXT, and then onwards. I started programming BASIC. Matter of fact, I started programming batch files. And I was like, oh my god, I can do menus on a PC. And it was amazing. From batch files, I went to BASIC. I was able to find in some library somewhere a Pascal book, and then I started doing some Pascal. Then I took a turn to this language. Raise your hand if you've ever heard of this one, IFO. Yeah, I didn't think so. But anyways, it was a pure object-oriented language. It was the first pure object-oriented language that I've ever played. It's actually super funny because it's interpreted like Java, right? You don't compile it. So they went to this step that they called, freezing. You froze your code, which was super unperformant. Like it was horrendously bad. But then you could melt it. And like melt, try to compile into some native code, but it's a great language, by the way, to learn object-oriented programming. I've been deployed in production, anything like it. So at that point, I started understanding performance. I started falling in love with graphics, and from IFO, I went to C. And maybe I'm 10, 11, 12 now, and then my C days were kind of boring. So I wanted to move up and down. So I did some C++, I moved up the food chain, and I did some assembly. And I moved down the food chain, and that takes me kind of sort of through, assembly was fascinating to me. It's the first time I understood how a computer actually worked. And at that point, I understood how much I did not know about how a computer architecture actually worked. I remember spending a ton of time with little breadboards, trying to essentially wire breadboards together because I was determined I would do a video game. And my video game was some James Bond something where I got super excited because I could make some LEDs blink. And the usual, right? And through that process, again, fortunate enough, by now I was able to apply to college. I got into college in the United States. I was able to go to Rochester Institute of Technology, now say New York. And then I actually learned how to become a software engineer. All the stuff before that was fun and games. So I did that. And a couple of years in college later, I find myself at Microsoft. And they said yes, I was surprised. I was excited, and the rest is history.
That's quite the journey, and I say quite the journey because I know from your profile that in the time that you've been at Microsoft, you're credited as the primary inventor on over 150 patents, so an extremely prolific career, right, everyone? So can you tell us a little bit about your time at Microsoft?
Sure. They give these little black cubes when you get a patent at Microsoft, so I'm not competitive at all, but I was determined to have more cubes than other people, so that was the motivator. At Microsoft, my first job was working on the first version of the CLR, so the CLR 1.0. It was 2001. Microsoft had been working on it since I think 1997 secretly. And it was rather fascinating because I joined essentially, CLR ships October 2001. I joined June 25th, 2001, now that I was counting. And if you join as a fresh out of college engineer at Microsoft, towards the end of a product cycle, basically they give you the most horrendous bugs to go fix. They say, your job is to learn the code base. Here's the database of issues that we're about to go ship, and we need to burn bugs down. Go nuts. And that's what I did. I was working on IL, which is the intermediary language that the compilers for .NET compiled into, right? The key thing about CLR is that you can program with several different languages that have their own syntax, their own compilers, but ultimately all of them compile into IL, and the CLR actually just reads IL, or the intermediary language. So that was the space I worked on. And that's the place where if you care about security, and at this point in time, security was starting to become a real thing. We're trying to build vocabulary for security. The main threat model issues in CLR was around the IL. So I became a security bug fixer for IL, which was fascinating because it's a fascinating code base. Ahead of coming to Microsoft, I was a Java person, and I love virtual machines from a consumption end. To be able to create a virtual machine and being that code-based was just fascinating. Now, it was both fascinating and horrified when I got to Microsoft. I was fascinated because I discovered this thing called debuggers. Here was I had been coding for my whole life. I had done a lot of things. I had never used a debugger. I didn't code in Windows. I didn't use Visual Studio, so debugging was like a thing that I could not comprehend. The first time I stepped into code, instead of printfing my way through it, I was in love. I was like, holy, how did I miss this for my entire life? I was also horrified because Microsoft still used some archaic build system to do it. So I was completely puzzled. I'm like, how is a place like Visual Studio that is amazing in debug things, that has IntelliSense, not build all of Windows in the CLR? They use build.exe to do it, make files. I couldn't understand it, so I walked into the person that ran Visual Studio's office and I said, hey, what's the story? Why don't you actually build Windows and CLR and everything with Visual Studio? He gave me an answer that was appropriate. He said, well, I think you like IntelliSense and the debugger. The reason you like those is because we're running a compile stack all the time, and it has to be a fixed build system. Well, I cannot comprehend that to be a true answer, so I synced to the Visual Studio sources that weekend and several weekends thereafter, and wrote a declarative build system, much like I had seen Java land with a build system called ANT. I repiped all of Visual Studio so that IntelliSense would work, so that the debugger would work. I walked into that same general manager's office and I said, hey, can I show you something? He said, sure. I said, found your project, WinForm project, drop a button, double clicked on it, put a breakpoint, tapped into it. He said, why are you showing me my product kit? I'm like, ah! And I showed them that the whole back system was a declarative system that I called, cleverly enough, XNate. That became MS Build. That was my first project at Microsoft. They put a team around me after that and said, just go ship that. We shipped MS Build on that 1.1. We shipped a year or so later, and I got hooked. I got hooked with innovation and doing things from scratch. So from MS Build, I went to Windows. Began around the componentization of Windows. Windows was somewhat spaghetti at the time, and if we wanted to create a new SKU or change features around the dependency chain was something that wasn't really known. So because of the declarative build system and all of this work, I actually did a lot of the componentization across Microsoft, which yielded any number of things, and ultimately shipped Windows Vista. And at the time I shipped Windows Vista, again, I had never worked so hard in my life, and it wasn't a great product, right? Customers did not love it, and that was super disappointing to me personally, because I worked super hard on it, and we all work super hard on it. It never feels good to ship something that people don't love. So I had a midlife crisis. That was my midlife crisis. I was 27, and I'm like, life's over. I've worked so far, since I was 6 to this moment in time when I'm 27, only to create something that's, people don't love. So I kind of took some time off, and I was pissed off at myself. Really, I wasn't pissed off at anybody else, because I didn't have a point of view. I was doing what other people were asking me to do and work on. Since I had joined academia and Microsoft, people would tell me what to do, and I would do it. And I said, that's no good. My favorite Nietzsche quote goes something like, he who has a why to live for can bear almost any house without purpose, search for meaning. And I'm like, I don't have meaning. I said, since I was a kid, that this was my art form, I should have a point of view, I should have purpose. So I went back to Brazil. I spent about 6 months in Brazil walking around and figuring out what is my purpose for computing, what is it that I want to do for the rest of my life. And ostensibly, I came out with the conclusion that the best way to predict the future is to understand the past, which in our case makes all of us extremely lucky because computing hasn't existed for more than 100 years. Think about any other art form. You have to learn a lot of history to predict forward. In our case, 1940s, computers are born, right? 4 bits later, we're racing forward to calculate atomic chain reactions, and the rest is history. Computing is pervasive through every moment of our lives. And it's interesting, back to purpose, to ask why. Why is it that we use computing from the moment we wake up to the moment we fall asleep? I gather that it's for 2 reasons. Computing essentially allows us to do 2 things that nature does not allow us to go do. It ostensibly allows us to displace space. It allows us to displace time. Doesn't matter if you're working, if you're communicating, if you're learning, or if you're being entertained. At the end of the day, if you think about it, no matter what you're doing in any of those scenarios, you're actually displacing space or time. Let's go home tonight, let's watch television. That's like watching theater, time and space displaced. Send an email, you're displacing time. Take a walk with me on Mars, you're displacing space. And I'm like, aha, eureka! That is the root purpose of computing, displacing space and time. Once you apply that lens to the world, everything else becomes horrifying. You're like, everything else is a con.